I want to talk just a little bit about the graphs of logarithms. Let's take a look at the graph y equals log base 2 of x. Base 2 is a nice convenient base to use when we're graphing. And let's pick values of x which are easy to take the log of. Let's start off with x equals 1. Log base 2 of 1, what power do you raise 2 to get 1? Well, the log base anything of 1 is equal to 0. Log base 2 of 2, what power do you raise 2 to get 2? Well, you raise 2 to the power 1 to get 2. So this is just a 1. Log base 2 of 3 is not easy to compute, but I could easily compute log base 2 of 4. What power do you raise 2 to get 4? Well, you raise 2 to the second power to get 4. And if I plugged in 8, which is another thing, if I plugged 8 in for x, log base 2 of 8, what power do you raise 2 to get 8? Well, you raise it to the power 3. Now, of course, I can't plug 0 in there. You can't raise 2 to anything and get 0. And you can't raise 2 to anything and get a negative number. But I could put some things that are less than 1 in there. If I said, what's log base 2 of x equals a half? If I put a half right where x is, well, what power do you raise 2 to get a half? We did lots of this last week. You raise it to the power -1. And if I put a quarter in for x, what power do you raise 2 to get a quarter? We raise it to the power -2. Let's plot those points and see if we can sketch ourselves a picture. So here's my x-axis, and here is my y-axis. So 1, 2, 3, 4, 5, 6, 7, 8. That ought to do it. For the x-axis, that's as far as I went. And 1, 2, 3, 4. I'm going to leave it there for now. -1, -2, and so on. Well, we have a point at 1, 0. We have a point at 2, 1 over 2 up 1. We have a point at 4, 2, so over 4 up 2. We have a point at 8, 3, so over 8 up 3. Clearly, this is not a straight line. We have a point at 1/2, -1. So we'll go to x equals 1/2 down to -1 at a quarter. So there was a half, here's a quarter at -2. I think you might already have a pretty good idea what this thing looks like. And it keeps growing as we go to the right, but it grows slower and slower and approaches the negative axis asymptotically. So y equals log base 2 of x. Now, in the last video, we said that log was the inverse of exponentiation. And you know the relationship between the graph of a function and the graph of its inverse. They are just reflections in the line y equals x. So the line y equals x, of course, is the line which goes through the origin and goes uphill at 45 degrees. So log base 2 of x is the inverse of the curve y equals 2 to the x. We've already graphed y equals 2 to the x. It goes through the point 0, 1. It goes through the point 1, 2. It goes through the point 2, 4. It goes through the point -1, 1/2. It goes through the point -2, 1/4. It goes through the point 3, 8, and so on. It looks like this. So y equals 2 to the x approaches the negative x-axis asymptotically and then grows very rapidly as we go to the right. These two curves, you can see, are mirror images in the line y equals x. Since the curve y equals 3 to the x has more or less the same shape as the curve y equals 2 to the x, then the graph log base 3 of x is going to have more or less the same shape as this curve.